Hello, welcome back. Sorry, my memory died. Not memory, no more memory in my phone. Okay, let's continue. I was talking for another 5 minutes until I realized. Okay, so I was over here. So we were talking about how we combine the acid and alcohol to form ester. So we have ethyl propanoate. So if you remember, we cut it and we count the acid first. So 1, 2, 3, propanoate ending, and then we have 1, 2, ethyl. Okay, remember to add H2SO4. Now, normally we'll use one way only, so the reaction is not reversible. But for this esterification, you need to know that it's reversible. Okay, so you can never use this anymore for esterification. So you must remember to be reversible, because the next part we're going to learn is how ethyl propanoate or ester will break down into acid and alcohol. Okay, so now we move on to the next one. If the question is given you anything with benzene, so we just still find the main functional group. Over here we have COOH. So in this case, this is a side branch. So we call it phenol. And then Me, ethanoic acid. Here we have a propan-2-ol. So it's a secondary alcohol. So when these two react under H2SO4, so we just have to remember that acid will lose OH, alcohol will lose only H. So when these two are gone, this will combine to this part. So we will have something like this. So the acid will lose OH, and then the O will combine with the remaining C. So to name this molecule, we have to look at the acid first. Me, so this is the main chain, so ethanoate. This is a branch, so phenyl ethanoate. Next, for propanol. Now this one is propan-2-ol. Now if you remember last time, there's propan-1-ol and propan-2-ol. So in this case, it's propan-2-ol. That's what we have to put 2 at the front. Now, if it were propan-1-ol, we would have put in 1 propyl phenyl ethanoate. Okay? So this is basically about the naming and how the reaction happens. So what happens in the lab? How do we make ester in labs? So on page 109 over here at the bottom, okay? So you will able to see this paragraph, okay? You will see how important this is. So in the past, CEs and A levels have asked a lot, but at this moment, DSC have not asked anything yet. So you have to watch out for this one. So put a star over here. So what is this? What are they talking about? Is if I have ethanoic acid react with sulfuric acid, I have to warm it. Okay? Why do we warm it? Why don't we heat it up under a Bunsen flame? Sidra. Wrong. Okay, the answer is because ethanol is flammable. Okay, so write it down, flammable. Alcohols are flammable, as you know. So if we directly heat it, it can be very, very dangerous. So what we do instead is we put it in the water bath. And now after the reaction finishes, now you will notice, please highlight this part. We pour it into sodium carbonate solution. All right, put a star here again. Now many of them always forget this step. We do not pour it back into water, or we just don't pour it like that in the beaker. Because this reaction, mixture, we don't know whether it is 100% reacted or not. We don't know whether all of ethanol has reacted with all of ethanoic acid. And we're not sure that we have used up all concentrated sulfuric acid. So therefore, there will be residue, which means there will be unreacted ethanol or ethanoic acid or sulfuric acid. So the product given out will not be pure. So therefore, we have to mix it with sodium carbonate. For what reason? Now, ester has COOC bond. Now, this is very soluble in water. Okay, because it can form hydrogen bonds with water. Now if we have water, it will dissolve in water, so we cannot separate it. So instead, we put sodium carbonate. Okay, sodium carbonate it's not really soluble when we dissolve ester inside. So what happens is ethyl ethanoate will float. It will not be soluble inside. The rest, there will be soluble inside over here. Okay, so we will have two layers formed. The top layer will be ethyl ethanoate, which means the ester. Okay, the bottom one will be something we don't. So there will be two observable changes. Okay, number one, we will be able to observe insoluble layer. Second will be the sweetish smell can be detected. So anything that is smell, can see or can hear is under the category of observable changes. So we have two observable change here. Please write this down. So this is what we do in the lab. For simple esterification. In reality, to ensure complete reaction, we will do it under reflux. Okay, we can do it under reflux as well. Okay, so there are two possibilities. Do you need to know how to draw setup for this one? Not really. But if I usually in exams in the past, they will say, all right, you have to write it. You have to draw the setup under reflux. So if you have to draw under reflux, so you can turn back to the previous pages. For instance, page. This one. On page 85. So this is a reflux setup. So instead of having haloalkene or sodium hydroxide, what you will be adding, it will be the alcohol, the carboxylic acid, and the concentrated sulfuric acid. Okay? After reflux, so how do we separate it? So if I want to separate it, I will be using condensation method, which is this one. I'll condense the distillate out. Alright? So this is for, so you'll notice for alcohol to aldehyde or ketone, we also have the similar setup. Okay? So what you do is you just memorize one setup and you're just changing the reactants. Okay? So moving on to the next part. On page 110. Now we have talked about esterification. Now another reaction, all right, will be reduction. Now what is reduction? So it's actually quite straightforward. So if you remember, for alcohol, for primary alcohol, let's say if I give you ethanol, if I undergo oxidation, I will get aldehyde. If I keep going, oxidation, I will get carboxylic acid. So this oxidation, the reactant will be what? So the usually one will see K2O7, Cr2O7, and then add acid. So the oxidizing agent, so same thing for this one. But now we are here. So how do we go back? Yeah, so the process will be reduction. So for reduction, if I want to go back to this step, it's impossible, so we cannot stop in aldehyde. So whenever we get carboxylic acid, we always go back to the primary alcohol. So let's look at this example. So we have propanoic acid. Now if oxidation is going this way, the reverse will be reduction. So what is the reagent used? So for reagent, we will use LiAlH4, ethoxyethane, and acid. So I'll just convert this whole thing. Okay, this whole thing will be gone and it will just give alcohol. Now, notice that in this page of the textbook, they have been using LiAlH4. Now, what if you ask, can I use NaBH4? In this case, we cannot use NaBH4. Now, the reason is very simple, because NaBH4 is a weak reducing agent. You will see this in the top left of page 110. Weak reducing agent. It is not strong enough to reduce this into alcohol. So therefore, you have to memorize this one. Okay? So whenever we're given any form of acid, carboxylic acid, and I add a reducing agent, I will always get a primary alcohol back. So this is another reaction for how to form acid to alcohol. All right, we have learned how to form alcohol into acid by giving oxidation, using oxidizing reagent. So in this case, we will move it back to reducing agent. Now, these are common sense because you have seen through. Now the next part, at the bottom of page 110, it's something new. Now this one is converting carboxylic acid. Okay? Carboxylic acid into amide. So if I have COOH, basically I will be converting OH into amide. Now how do I do that? Again, in order to form OH into NH2, so what is the source for NH2? At this moment you have only learned one, and it's quite obvious. It's a gas. Okay? So yes, that's correct. It will be ammonia. So what we do is, if we have acid reacting with ammonia. Now in the textbook it has shown you step by step, so I'll explain why they show you step by step. So it's this reacting with ammonia, I will get C double bond O, and then I will have oxygen over here. Now since this H will move into this, I'll get ammonia and then NH4 positive. So I'll get ammonium ethanoate. Okay? So, do you have to know this? Just get to know it now. They will not actually ask you to write the equation, but it's good to know the middle step. So I have ammonium ethanoate. Okay, it's a salt. What I do is, if I heat it up, if I just heat it, I will get the aldehyde. The amide. So this will form NH2, and then plus water. Because you will notice that, why will I get water? We have O, and then we take out how many? 2H. So 2 of the H and O combine to give out water. So NH, 2 of them left, will combine with this main chain to form amide. So therefore, we'll form an amide. So because this salt contains a lot of water, so the reason why we heat it up is because we want to dehydrate this to get amide only. So what do you have to know is just this. So if a question gives you, something like this, very long chain, carboxylic acid, and then I want to convert carboxylic acid into this, 1, 2, 3, 4, and then OH. Now this is very important because of synthesis. If you remember, use 2 or fewer steps to form this product. If you remember those type of questions, you have to know this. How to convert carboxylic acid into amide? What you do is, basically first you need ammonia, and then what's the second part? The second part will be, yes, heat. So you just ammonia and then heat, and that's all you have to know, and you can form amide. So you will see on page 111. Which ones do you have to know? Actually all, but for this part I would like you to be careful. You can actually use one step, so you can add an arrow over here. So just do aqueous, ammonia, and heat. So what I did over here in this paper, so ammonia and heat. So you can do one way. Here they just broke it down into 2 steps. And then reducing agent, so I can convert acid into alcohol. Acid react with alcohol with another acid, so I will get ester. Now if I react it with sodium hydroxide or sodium hydrogen carbonate, the one I showed you very first, I will get a salt only. So sodium propanoate. So remember, ending is ATE because it's a salt. So these are the reactions for carboxylic acid. Okay, so now revise it through on your own. I'll give you 5 minutes or less than 5 minutes. And then the next part will be, I would like you to attempt this question. All right, questions 1 and 2. Now question 1 is talking about the reaction, basically the setup and what are the importance of it. And then question 2 is empirical formula and deduction. So they give you the mass and then they ask you to deduce what is the molecular formula of Z. So please do it in 5 minutes, 5 to 10 minutes, and then I will explain the answers in the next clip.